Welcome back, everybody. This is going to be our review lesson on volume of prisms and cylinders, lesson 35. So hopefully you guys watched the video for the classwork, in where we really talked about our basic understanding of finding the volume of a prism or cylinder. Really is going to be find the area of the base figure, because the base figures are those two congruent shapes that are basically, that are basically the top and bottom of each other, if you want to look at it from that point of view. Or and in this case, you would take the base area times the perpendicular, the height or depth in this case. So we're going to apply that here for the first question. The following wedge prism has a volume of, and now, so we have here, it's a right triangle. So it's a right triangle. Otherwise, there's no way we'll find this answer here, because there's no angles here. So this is really going to be a right triangle. I'll put a little rectangular symbol here to form a right angle. Okay, so this is a right triangle, and this is the congruent right triangle here too. So okay, all right. So that means in this case we're going to find the area of the triangle. It's going to move this a little bit. Oops. Okay, it's fine. Oh, oops. Ugh. Things are falling apart. Sorry. Okay. Hopefully it's okay. Now, the area of the triangle can be found by taking 1/2 base times height. So area is equal to, in this case, 1/2 base times height. All right. We'll actually use a big H for the for this. Okay. I'll use big B for base. All right, so now the base, so here's a bit, actually, let's little h, sorry, this is for the triangle. All right, so, okay, so let's fill this in here. So we know in this case the base and height are the perpendicular distances to each other, so our area is equal to 1/2 times 2 times 4.5, which gives us really 4.5. But we're going to take this base area, because this is really the base area, and volume is equal to base area times our capital H for the height. That's really what capital H was for. And this part here, the capital H would be the depth here. And so we're going to take the 4.5 and multiply it by the 6 inches. We're going to get a total of 27 inches cubed, or cubic inches. Would that be choice 3 here? So we want to find the area. So the area of the triangle, this triangle here, that was 4.5 inches squared, and then we'll multiply that by the depth here, or the height. Okay, so let's take a look. We'll do another problem concerning volume. And so we have a right circular cylinder with a diameter of 14 inches and a height of 10 inches. Has a volume in cubic inches of which the following. So we're going to now draw a figure here. So let's see now, get some shapes here. Okay, so here we go. So here's a top of our cylinder, and then I'm gonna, you guys want to go, how does he do this? No, I'll just take the top cylinder, I'm gonna clone this to get the same exact shape. So, all right, and then we'll make the height 10. Hopefully it'll be lined up properly. We'll see. So here we go. Oh, it's off by a little bit. That's okay. I can shift it over a little bit. So okay. Move this over, and so the diameter is going to be a measure of 14 inches. So our diameter here, our diameter going across, will be 14. Now the thing is this, and this will be 14. Okay, I'll write in 14 inches. While the height of the cylinder is 10 inches. Well, the idea now is that our volume of a cylinder is going to be given to us as the base area, which is going to be pi r squared, that's a circle, times the height. Okay, so the idea is that we need to find the radius. So if our diameter is going to be 14, our radius is going to be 7 inches. So we'll take our volume of a cylinder is pi times 7 squared times 10. Well, 7 squared is 49, and 49 times 10 equals 490. So our volume really is 490 pi inches cubed. And that'll be choice 2. So we should set up our formulas in this case. It's good to have them, but the basic formula for these volumes is going to be the base area times the height. Now let's go into our next question. Here, a box tube is constructed out of 1 centimeter thick metal that has a width of 10 centimeters, a height of 6 centimeters, and a depth of 15 centimeters, which the following is the volume of the metal used. Well, okay, so the idea is that you got this kind of a box, but in the middle of this box is cut out so it's a tube. And so we're going to take exactly what we're talking about, find the volume of the large rectangular box, and cut out or subtract the volume of the rectangular empty space. So our volume of a box is equal to our length times our width times our height. So our first volume, I'll call it the big volume, that will be, in this case, it will be, our length would be 15, our width will be 10, and our height is 6. And if you multiply that together, if you multiply 10 times 15 times 6, well, 15 times 6 is 90, and then 90 times 10 should be 900. Okay, so that'll be 900 centimeters cubed. Now the volume of the small of the US, the smaller piece, well, okay, we know the length is be 15. But if we were to redraw this box here, the empty space, this is still 15, so that's okay. However, this measurement is not 10, because if each of the sides is going to be 1 inch, that will mean that I must take 1 inch from the left side and the right side. Therefore, 10 minus 2 is 8 centimeters. And if the height is 6, then I must take one from the top and the bottom. Therefore, 6 minus 2 will be 4 centimeters. So now this volume is going to be 15 times 8 times 4. Okay, well, in this case, 4 times 15 is 60, and 60 times 8 is 480. So this volume of the tube is going to be 480 centimeters cubed. Well, in this case, we take the shaded region, if you will. We're going to subtract the volume of the big volume minus small volume, very similar to our shaded area problem, except with volumes. So it'll be 900 minus 480 will give us 420 centimeters cubed. And that's going to be choice 1. Okay? All right, ladies and gentlemen, so we see in this case that we're very much like doing a shaded region problem, but instead of just shaded areas, we're doing shaded volumes. Okay, so number 4. A large plastic bucket is in the shape of a right circular cylinder with dimensions shown. And dimensions are radius of 15 and a height of 28 centimeters. If there are 1,000 cubic centimeters in a liter and 3.785 liters in a gallon, then which of the following is true about the volume of the cylinder? Well, here's the thing. We need to find the volume first. So let's sub our volume. Volume is equal to pi times the radius squared. So our volume is equal to pi times 15 squared times 28. Now let's break out a calculator. This one's going to be, and we're going to keep it, in this case, on our calculator, and we're going to do adjustments based on the full amounts, not going to round off. So we have in this case pi times the radius squared, which is 15 squared, and then we're going to multiply that by 28. So we're going to get a volume of 19,792.03372, and it goes on for a little more, cubic centimeters, okay? So I believe 19,792.03, I think it was 03. Let's double check to make sure. Yes, 19,792.03 centimeters cubed, okay? Although there's some more spaces afterwards. Now, it says here there are 1,000 cubic centimeters in a liter. So we're going to take this because we have, these are cubic centimeters. We're going to convert to liters though. So we're going to take our volume and divide by, so we divide this by 1,000. Enter that, and we get 19.79200. So we divide by 1,000. And this is just going to be a kind of a decimal shift. So 19.792.79203 dot dot dot. Okay, and this is liters. This is no longer going to be cubic centimeters, liters. But then it says a gallon has a 3,000. So there are 3.75 liters in a gallon. So we want to take this number and divide by 3.785. Okay, so let's take this and divide by 3.785. 3.785. And we will find in this case, we get about 5.229, so about 5.23 gallons, actually, gallons. And so therefore, we're looking for, now, it's not asking for the exact or rounding off, it's just between values, and we see 5.23 is between 5 and 6 gallons. So we have to show all this work, and we do each part separately because we don't want to rush to it. We could technically type it in the calculator, but the reality is that we want to take a look and process all these things. We're converting from cubic centimeters to liters to gallons, right? Which is a very normal thing to do because a lot of times some items will come in using a metric system, and we'll have to change them into our English system of measurements. So, you know, just to keep that in mind. Ladies and gentlemen, this is the end of part 1 for our homework review of lesson 35. Volume of prisms and cylinders. I hope it's helpful. If it was helpful to you, please, I appreciate you give a like and leave any questions and comments in the comment section below. Subscribe to our channel and turn on notifications to know when new videos are added to the channel. Thank you so much for watching. And if you have any suggestions or things, because we're probably going to continue on with our lessons into our next topic from geometry into algebra 2. So probably going to go into that later on once we're done with this. And also just know that, you know, a lot of you who are progressing to the next level, you know that you will not be alone, that you will have these videos available to you for help. Thank you so much for watching today, ladies and gentlemen, and watch out for the next video, part 2. Take care. Be safe.